Welcome to Hydraulics and Hydraulic Machines class. In this class, we deal with some more concepts in centrifugal pumps. Today's lecture will focus on two things. Number one is what is the work done by the impeller on water, thereby the energy is transferred to water. Please remember, in case of a centrifugal pump, work is done by the impeller on water. Work is done by impeller on water. The impeller is already rotating because of the electrical motor and it possesses some energy. It transfers that energy to the liquid which comes in contact, that is water. Thereby, the water is lifted from a lower elevation to a higher elevation. So kindly remember, work is done by impeller on water. Whereas if you recollect 1 minute regarding the turbines, there actually the in case of turbines, especially the reaction turbines, if you see, the water rotates the runner. Water rotates the runner. Work is done by water on the runner and energy is transferred from water to the runner. This is the fundamental difference between a turbine and basically a centrifugal pump. How the work is being done, which here in turbines, work is done by water on the runner. Because of the work done by the water, the runner is being rotated. Whereas in the case of centrifugal pumps, the water which comes in contact with the impeller is rotated by the impeller. Impeller is already rotating. Water is not rotating the impeller. Impeller is rotating the water. Thereby, the impeller actually transfers the energy. Work is done by the impeller on water. This is first. What is the equation for it? That we will see as a first topic. Once that is completed, then we will go to the working principle of centrifugal pump. These are the two topics which we discuss in today's lecture. So the focus for today is work done by impeller on the liquid. This is the we all know that in the case of centrifugal pump, work is done by the impeller on water. This is first thing. How basically actually the impeller imports energy to water. That is the thing. So how do we derive the equation? The equation for work done can be obtained by drawing the by drawing the velocity triangles. Anywhere, this is the only way. The velocity triangles at inlet and outlet. Now, what are the how to draw the velocity triangles actually, right? So you know basically first thing is how the water enters. water enters radially at inlet for the best efficiency of the pump. First thing is that best efficiency of pump. Water enters radially. So when water enters radially, the alpha is equal to 90 degrees. That is the first thing. When alpha becomes 90 degrees, then naturally V1 is equal to Vf1 and Vw1 is equal to 0. I will show you also in the figure how it looks like. For example, if you see, just I'm showing it. So that, for example, this is how it's only some part of the thing impeller I have drawn. You need to continue the same thing. So the vein portion, if I take it, right, this is the vein portion, like radial vein, which we have done initially. Now, if you take it actually, so this is first thing is here water enters radially. This is the first thing. When water enters radially, this is how it will be, right? Then basically second thing, it is moving in this direction. So this is U1. This is U1. Now if you connect these two, this is what VR1 is. Exactly, if you remember, this is the outlet velocity triangle in the case of radially inward flow. But here it is radially outward flow. So that's why whatever we have drawn at the outlet has become the inlet velocity triangle. So naturally here this alpha, whatever it is equal to 90 degrees. Therefore, V1 is equal to Vf1 and Vw1 is equal to 0. So as far as this is concerned. So next one is, this is what the inlet velocity triangle. Outlet velocity triangle. Outlet velocity triangle also same thing. The water leaves radially. So this is how it will be. So it is equal to Vf2, the velocity of flow. Then what happens actually, how the V2 looks like. V2 is, this is how V2 is going to be, right? And this is U2 and this will be VR2. And this angle is beta, this angle is phi. The VR1 makes with horizontal, this is theta. So these are the things. This is the outlet velocity triangle. Important things are Vf1, Vf2. Both, if you see it, radial at inlet and outlet. So that if you remember, that's fine actually. Automatically, this will become up to here. It is VW2. Rest of the things are all same, like N is equal to speed of the impeller. N is the speed of the impeller. All same notations in all PM. D1 is equal to dia at inlet. So U1 is equal to pi D1 into N by 60, right? This is equal to the tangential velocity at inlet, right? Then D2 is equal to dia at outlet and U2 is equal to pi D2 into N by 60. tangential velocity at outlet. This is next. Now, if I take it the inlet velocity triangle, for example, first inlet velocity triangle. Inlet velocity triangle, if you remember how it looks like, this is V1, this is U1, and this is VR1. This is theta. This alpha is equal to 90 degrees. V1 is equal to Vf1. Vw1 is equal to 0. This is the inlet velocity triangle. So what are the any doubts actually regarding this? V1 is the absolute velocity. Vr1 is the relative velocity. U is the tangential velocity. Alpha is equal to angle made by basically the absolute velocity with u, and theta is angle made by the relative velocity with u. So this is why, because why this alpha is equal to 90 because water enters radially. This is the first thing. Then actually first you very very important thing actually, a centrifugal pump is reverse of a radially inward flow reaction turbine. This is very, very important. Now, already we have derived, already we know for a radial inward flow reaction turbine, the the equation for work done by water on runner per unit weight of water. This already I have derived actually in the previous classes. It is equal to 1 by G into VW1 U1 plus VW2 U2. This is what we have already derived. So, but in the case of a turbine, you please see work done by water on runner. This is very important. Whereas in a case of centrifugal pump, in case of centrifugal pump, work is done by impeller. That means by the rotating element on water. Therefore, work done by impeller per unit weight of water, per unit weight of water is equal to minus of, right, work done by runner, work done not by, what should be there? On runner, on runner per unit weight of water. Just reverse. So therefore, work done by impeller per unit weight of water is equal to minus of 1 by G into VW1 U1 plus VW2 2. This is what we get as. Therefore, if I do it minus of 1 by G VW1 U1 VW2 U2, this is okay. Then if I take minus inside, it is 1 by G into basically VW2 U2 minus VW1 U1 minus if I take it for a centrifugal pump as alpha is equal to 90 degrees, VW1 is equal to 0. Therefore, work done per second per unit weight of water is equal to 1 by G into this becomes 0. VW2 Q2. Just recollect in reaction turbine. When I did Francis turbine, it is exactly 1 by G into VW1 U1. So there the inlet is equal to here the outlet. Whereas there the outlet is equal to here inlet. That's what I have done it here. Suppose you want what is the total work done per second is equal to work done per second is equal to 1 by G VW2 U2 into basically it is the weight of water. So it is 1 by G VW2 U2 into gamma Q by G into VW2 U2. This is what you will get. Then if you want actually how to get Q is equal to area of flow into velocity of flow. Area of flow is nothing but pi d1 into v1 into vf1 or pi d2 into v2 into vf2 that we can use and find out. So this completes to me the derivation for work done. Kindly note it actually in the derivation for work done. What we have talked is it is 1 by G into VW2 U2. So let us take the working of a centrifugal pump. First, what is the principle? A centrifugal pump works on the principle that what when a certain when a certain mass of liquid is rotated, this is rotated by an external source, by an external source, when a certain mass of liquid is rotated by an external source. But in the case of centrifugal pump, this is nothing but the rotating element is the impeller and the external source is the motor actually, right? Rotate by external source. It is thrown away. It means what? The water thrown away from the central axis of rotation and the centrifugal head is, please underline, a centrifugal head is impressed, which enables it, and it means the water, which enables the water to rise to a higher level. This is the principle. And how much, basically, the rise in pressure head, because when I say height means naturally pressure head, the rise in pressure head is proportional to the square of velocity. This centrifugal head is equal to, that is pressure head is equal to V square by 2G, as V is equal to R omega. Therefore, the pressure head is equal to R square omega square by 2G. This is the thing. And how now a centrifugal pump works. How a centrifugal pump works. First step. First, what we need to do, the delivery valve is closed. The delivery valve is closed. You have to first close the delivery valve which is there on the delivery pipe. Prime the pump if necessary. Then what is priming? Filling suction pipe, casing, filling suction pipe, casing, and portion of delivery pipe up to delivery valve is called priming. So this is what the first thing. So do it. If foot valve is functioning properly, priming is not required. So this is the first step. Once this first step is completed, then basically keeping the delivery valve in closed position, start the pump by switching on the motor. This is the second thing. Then after that, the third step, what you will do actually, when the moment you switch on the motor, nextly impeller starts rotating and basically a strong suction or vacuum is created at the center or eye of the pump. The speed of the impeller is gradually increased. What is the next step? Is gradually increased till it attains normal speed. Till it attains normal speed. Then open the delivery valve. The liquid is sucked to the impeller, and impeller rotates the liquid and pushed to higher heights. Water is lifted, water or liquid is lifted from the well or sump to the overhead tank. So this is the way it basically the centrifugal pump works. Actually, once more point also already I mentioned, as the casing is of spiral casing, casing also converts the what you call it as the velocity head into pressure head. Thereby, the water which comes out of the casing will have higher levels of pressure head. So long as basically so long as the impeller is rotating and the liquid is applied to the pump, the liquid will be lifted. Last point is when the pump is to be stopped, when the pump you want to stop it, when the pump is to be stopped, first close the delivery valve. First close the delivery valve. Then switch off the motor. That's it. So kindly remember that the same most important points in the case of the centrifugal pump working is what is its principle. That is to be first you should really able to understand the principle of centrifugal pump, which states that when a certain mass of liquid is being rotated by an external source, this mass of liquid is really moved from a lower elevation to a higher elevation. It is thrown away from the central axis of rotation, and a centrifugal head is impressed on the liquid actually. So that is the principle on which it works, because that centrifugal head is nothing but is equal to square of the velocity. So with which velocity it is moving to the square of the velocity, the centrifugal head is equal to. When I write it in terms of head, it will be v squared by 2g. So this is the large amount of head actually. So then what you do is, already the steps wise I have explained. Please remember that in the suction pipe always the pressure is less than atmospheric pressure. It is vacuum pressure. How the vacuum is created? When the impeller initially, when you close the delivery valve and starts the impeller to rotate actually by the external motor, naturally what will happen? Strong suction is created and it sucks the liquid from the sump actually, and the energy is imparted to water. Then if you open the delivery valve with that energy, the water leaves it. At the point when the water comes out of the impeller, it possesses both pressure energy and kinetic energy. But because of the spiral casing, that velocity head is also being converted into pressure head. A large pressure head will be there for the water when it comes out of the casing, and that's why it is lifted to a larger heights. So with this, I will close this topic and will go into the next topic, wherein we study regarding the different heads and efficiencies of a centrifugal pump. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.